Hello, my name is Tony Wong, and I'm an engineer on the Cloud Foundry Container Runtime team, also known as CFCR. This is a walkthrough of installing CFCR and deploying Kubernetes with it. CFCR used to be called Kubo, so you see a lot of references to Kubo in this video, and we're trying to fix that. The goal of CFCR is to simplify the deployment and maintenance of a Kubernetes cluster. There's a lot of stuff that an operator has to worry about day to day, and CFCR helps them ease that burden. It has features like enabling self-healing when the VM goes down, generating, installing, and managing certificates and credentials, monitoring the health of Kubernetes processes like proxy and API server. It also makes deployment and scaling up a lot easier, more repeatable, and easier to automate. It supports a lot of different cloud providers. Right now, GCP, AWS, vSphere, and OpenStack. And finally, it supports rolling system upgrades. So that's a huge list of stuff that operator has to worry about, and CFCR is our solution to that. How does it do that? It actually works off of the tool called BOSH. Let's take a look at BOSH now. BOSH is a tool chain that helps people operate and deploy complex distributed software. It was designed to run Cloud Foundry, and now we can use it to run Kubernetes. Actually, if you understand the Kubernetes architecture, it helps with understanding BOSH because the two have analogous components. For example, here is the BOSH director on the left. It's similar to the Kubernetes API server. It takes commands from a CLI and then turns them into tasks and schedules it to be run. It also looks at the current state of the system and reconciles that with the desired state. Furthermore, it sits on the same network as the rest of the system, all the services. Right. It watches over a group of machines, these boxes on the right here. These are all VMs that BOSH manages. On each VM, there's something called a BOSH agent, which looks over the processes. For example, on this machine, there is the scheduler, the API server, and the controller for Kubernetes. The BOSH agent takes a look at all the processes and monitors them and makes sure they're all up, and restarts them if they ever go down. The BOSH director also has something called a health monitor, which looks at the health and liveliness of all the VMs. If it notices that VM has gone down, it resurrects that VM and makes sure that it joins the cluster properly. In our case, if a worker node goes down, BOSH director will restart another VM, turn it into a worker node, and make sure it joins the cluster properly. And finally, we have the idea of a BOSH release. A BOSH release is what package software is called in the BOSH world. And here is where it starts to diverge from Kubernetes a bit. A BOSH release takes all the binaries and libraries and scripts necessary to deploy a system, and it packages all that into a tarball. And that's what a BOSH release is. CFCR is one such BOSH release. What CFCR does is it packages the scheduler, the config, the controller, the API server, all those binaries. The libraries need to run etcd, the scripts need to run flannel, and any necessary configuration, and it puts them all in a tarball. And with this tarball, we call it a BOSH release, and we can distribute it to our users. The user takes that CFCR BOSH release and then uploads it to the BOSH director, along with something called a manifest, which provides a way to customize the networking and Kubernetes settings. The BOSH director takes both elements and then starts the deployment. When the deployment starts, the BOSH director takes a look at the manifest and kicks off as many VMs as it needs. For example, if it needs one master VM and 3 worker nodes, it'll kick off 4 VMs and it'll start monitoring them. If those VMs ever die, the director knows how to resurrect them. It'll then compile the libraries that it needs, including Golang or the CNI, and then with that it takes all the binaries that it has, including the scheduler here, or the controller, or the kubelet, and it places all that in the correct VMs. Then it places the configuration for those programs and kicks everything off. And the BOSH agent will monitor those processes, and if they ever crash, it'll know how to restart them. That's basically it for a BOSH deployment. As you can tell, these issues are already this type of stuff that the operator has to worry about. I hope I made a good case as to how CFCR can alleviate a lot of these pains and help the operator sleep better at night. I think now is a good time to start our walkthrough. First, we'll start with the prerequisites for installing the BOSH director, and we'll actually go through the installation, and then we'll explain a little bit about the deployment process for CFCR itself. We'll use it to deploy Kubernetes, and then we'll do some verification afterwards. If you take a look at the CFCR docs, there's a whole section on preparing GCP for BOSH installation. So first, it starts with some prerequisites, an existing GCP project, an account with the owner role, and some APIs that need to be enabled. Then it goes to creating a VPC network, and then also setting some environment variables for an eventual Terraform plan execution. This Terraform plan creates a lot of GCP resources necessary for the BOSH deployment to work. Instead of just skipping over what's been created, I'm just going to walk through all the resources that this Terraform plan creates, and hopefully it gives you a deeper understanding of what's the infrastructure needed for BOSH. Now, if you look at the GCP console, you'll see that our project is called CF Sandbox T1. We're in the IAM panel right now, and you'll see that there's two service accounts with the K1 prefix. Inside the documentation, it'll ask the user to create a prefix of their own, so yours won't be K1, but it'll be something like that. One of the keys you created yourself with the owner permission, like we said, and the other one was created by the Terraform script. If you go to the VPC section, under Network Settings, we have the CFCR net, which we created during the documentation. But underneath of that, the Terraform script has created a subnet called K1US West 1 subnet. Yours will be named a little bit differently, but it'll be the same idea. You'll get a chance to specify the IP range and also the gateway. Let's take a look at our instances. Compute engine, VM instances. You'll see that there's already two VMs here. The first one, the BOSH Bastion, the reason it exists is because we recommend that you don't expose the BOSH director itself to the external internet. So in order to talk to the director, we created a VM here. The user can SSH into the Bastion, and then the Bastion can have access to the rest of the network. This is a security measure that we recommend, and for most of the video we're actually going to be working out of the Bastion. Second is our NAT machine. For those machines inside of our network that don't have external IP, when they make a request to the outside internet, it'll be routed through the NAT. So as you can see, both of these machines have external IP. If you go to our route section, you'll see that there is a new route created for that NAT. So instances tagged with the no IP tag, all external requests will go through this NAT. Finally, let's take a look at the firewalls. We have two firewall rules here. One is for the BOSH Bastion with SSH access in, and one is for network communication within the cluster. If we take a look, those VMs tagged with internal will be included in this firewall rule, and then they can all talk to each other. That's about it for prerequisites. Now we can start the BOSH deployment. To install BOSH, let's first SSH into the Bastion. So gcloud compute SSH t1-bosh /bastion. This is exactly the VM that we saw earlier on the GCP console. Alright, now if we take a look inside, the only thing I've put in here is the service account key for our admin, the owner, or the one with the owner role. Now let's download the Kubo deployment tarball. So go to the Kubo deployment GitHub page, look in releases, and you can just copy the link for the Kubo deployment tarball. Copy link, wget, When you go to the releases page, you'll probably find a newer version and you'll want to download that. This repo contains the scripts necessary to deploy BOSH, deploy CFCR release, and the actual release itself. Alright, we can just untar it from the home in the home directory. Next, we want to generate the configuration template. So execute Kubo deployment bin generate env config, and then we want to put it in the home directory. Call our configuration CFCR-config and enter the name of our IaaS, which is GCP. Cool, it's created the CFCR-config directory. Inside of that, you'll see the director.yaml. The director.yaml is where all our configuration properties are. Our scripts to deploy BOSH will read from it, and our scripts to deploy CFCR will read from it. So we're going to modify it now to include all our IaaS properties. Let's take a quick look inside. So director.yaml. If you browse around, you'll see that a lot of these properties are left blank right now for us to fill out, including the internal CIDR of our BOSH subnet, our gateway, the name of the director that we want, the DNS IP for custom DNS, a bunch of stuff. But since we prepared this bastion using the Terraform plan, there's a handy script that does all of this for you. Just execute usr/bin/update gcp env and then point it to the director.yaml. And it should be populated. So let's take a look again. As you can see, it has selected an internal IP for our future BOSH director. It's created a network name that's used internally within BOSH. It knows the subnet range. It's created a director name. It's pretty useful. Now we're ready to deploy BOSH. Let's go back up a directory and execute Kubo deployment bin deploy _BOSH, and it'll tell you that it needs the BOSH environments path and then the private service account key name. So the environment path is CFCR-config and the key is k1-admin service account key. Alright, the one that we had copied into this bastion much earlier. And we can kick it off. The whole deployment takes about 30 minutes on GCP. Let's skip ahead to where it's done. After the script is done, we now have a BOSH director. Let's take a look at our GCP console again. If you go to Compute Engine VM Instances, you'll see that there's a new VM. This is our director. I'm not going to talk too much about BOSH director, but there's a lot of functionality that's great, and I'll put a link in the show notes to indicate some documentation about where to get started to learn about BOSH. In the meantime, we're just going to take a look at what else has been generated in this script. If your SSH connection has timed out, you can SSH back into the bastion. Alright, we're in. If we take a look at CFCR config again, we'll see that there's a couple of new important files. First, there's creds.yaml, which contains the passwords, CAs, and certs important for secure inter-component communication in BOSH. Then there's state.json, which is generated during the BOSH director deployment. It'll be useful later if you want to deploy BOSH again with new features, or if you want to destroy BOSH. Now's the time to start the process of installing CFCR. First, we want to set up the network infrastructure for CFCR. Since there's so much to type in this part, we're just going to go to the CFCR docs. Go to installing, configuring, preparing GCP, configure IaaS routing, and configure load balancer. In this part, it shows you that with a bastion that's set up with the Terraform script, there's actually a Terraform file that's inside share Kubo deployment docs user guide routing GCP. So we're going to copy that Terraform plan. Here it is. We're going to copy kubo-lb-tf to the home directory. Alright, let's go back to the home directory. There it is. Next, looking back at the docs, we want to set a directory where the future Terraform state is going to lie. In our case, it's going to be home/cfcr/config and then terraform.tf state. Alright, that's all we need. Next, you want to apply the Terraform file with inputs parameters like network, project ID, region, and prefix. These parameters are actually set up as environment variables for you already if you had deployed the Bastion using our Terraform files from earlier. So copy the command and deploy. This Terraform plan creates a few resources. First, it creates a target pool to put the master VM. Then it creates a load balancer to point to that target pool. And finally, it creates a firewall rule to allow ingress into the master. The whole process takes less than a minute, and after that we can take a look at GCP console to see what's been done. So let's take a look at gcloud, compute, target pools, lists. Our script has created the K1 Kubo-TCP public target pool. It's going to put the master there, and it's going to put a load balancer in front of that. Let's take a look at the console. So in the load balancer section, you'll see that we created a load balancer called K1 Kubo-TCP public. It's going to have an external IP which will forward traffic to our master. This is how we're going to get access from the outside world into our cluster. Next, we'll have to update the director.yaml with information about our load balancer and our target pool. So look into CFCR config /director.yaml. Look for the entry for Kubernetes master hosts. Look for the one that's not commented out. And here we will insert the IP address of our load balancer. So here it is. Copy, paste. And a little bit below that, the name of our target pool. It is K1 Kubo TCP public. Alright, and that's about all we need. We can kick off deployment for CFCR right now. Just go to Kubo deployment, bin deploy K8, and the directory for your configuration, that's CFCR config, and just a name for your cluster. We'll just call this my K8 cluster. In our case, this deployment takes about 20 minutes. Your case may vary, so we're going to skip ahead until it's finished. After it's done, as you can see here, we have some logs for deploying a master and deploying some workers. Let's take a look at the GCP console. If we take a look, as you can see, there's more VMs here. If you actually go into each VM, they'll be tagged with their respective node type. So here, you can see it is a worker. All right, you can go through each of them and take a look at their tags to find out more information. Now we're going to set up Kubeconfig and finally be able to get out of the Bastion. So to set up Kubeconfig, we have created a helpful script. So if you just call set kubeconfig, it'll tell you the parameters that it needs. First, it needs your configuration environment, and then it needs your deployment name. In our case, the configuration environment is CFCR config. That's the directory we created before. And our deployment name is, you can remember, my K8 cluster. Cool. So now kubeconfig should be set up. And if you can just run kubectl get services all namespaces, you can see, let me shrink this a little bit. you can see that it has Kubernetes, Heapster, kubedns, the dashboard, and InfluxDB all running. So pretty good. And all that information should be inside your .kube/config. Let's create a new tab so that we're outside the bastion. We're going to use the gcloud CLI to copy the kubeconfig from within the bastion to our local computer. So just do gcloud compute scp, the name of our bastion, the location of our kubeconfig, and then we'll just copy it locally to the current directory and call it kubeconfig. Alright, that's pretty easy. Let's just do a test command, --kubeconfig, point it to our new local kubeconfig file, and let's just call cluster info as an example. As you can see, everything's working properly, and let's try something else. Let's get nodes. Oops. Get nodes. Alright, you can see our workers are all here, and maybe component statuses. Component statuses. Alright, everything is healthy. And finally, let's just take a look at all our services. So get services, all namespaces. There we go. There are all the services. Just like before, our kubeconfig works, and we can access the cluster from anywhere. This concludes my walkthrough of installing CFCR and using it to deploy Kubernetes. In summary, CFCR allows operator to easily deploy and maintain a Kubernetes cluster. It has a lot of important features like resilience towards IaaS issues. It can generate, install, and manage certificates. It can monitor the health of Kubernetes processes, and it actually makes the whole process repeatable and supported in multiple infrastructures: GCP, AWS, vSphere, and OpenStack. If you found this useful, please keep in touch with us. We're on Cloud Foundry Slack. I'm on Twitter. Please reach out to us and tell us what you think. Thanks.